We're going to have our fourth and last clicker session for this semester. During today's session, we will have a new tool associated with clickers, which will be the fastest responders. So after I present the question and I give you time to solve it, we'll go over the question, the choices, the statistics of your answers, and then there will be a slide where the fastest responders are listed with the fastest to the top five groups, and your names are going to be posted. Here we go. First question. What is the product of the following reaction? %, answered 2, 51% answered 3. So what is the product upon conditions number 1 and 2? It is CH3. It's an elimination, right? C, triple bond C, CH3. So you're getting an alkyne. Then you are adding D3O plus D2O, which means that you are going to get OD-D. Then you are going to tautomerize. So what do you get then with tautomerism? This deuterium is going to move over here, right? So the correct answer is 3. Let's see who got it first right. Rashid and Rewa, they got it in 84-94. And then Rayan and Farah in 130 seconds and 8.86. Then Omar and Bettina. Then Ibrahim and Khalid. And then Usama and Jawad. You ready for the next one? Here we go. The product of the following reaction has a molecular formula C6H12O. What is the structure of this product? This is a reaction right here. %, got it right. So this is an SN2 reaction. First you form an alkoxide and then you attack. Make sure you put the methyl group at the right position. So put the substituent at the right position. Let's see which group got it fastest. Anthony and Giovanni, they got it in 45-53 seconds. Rashid and Rewa in 49-28. Zainab and Hussein in 68-48. Rita and Tamara in 72-77, Julian and Joe in 74-22. These are only the top 5 groups, okay? You ready for the next one? Here we go. The major product of the following reaction is So you're split about this question. 17% answered 1, 40%, answered 2, 31%, answered 3, and 11% answered 4. So you have an alkene, the two groups are trans, and you are doing an epoxidation. This reaction is stereospecific. You started with groups that are trans, they must be trans in the product. And then this O18, this oxygen is an isotope labeled oxygen, it is O18. So we need to know which oxygen is incorporated in the epoxide. It is in fact this oxygen, the oxygen from the hydroxyl. So in the answer you do not have O18. And therefore your correct answer is 2. Let's see who got it fastest. Christopher Hakim and Ghassan Haddad in 10.97 seconds. Good job. Omar and Abir, Patrick, and then Fadi, Ghiyi, and Ziyad Ghazawi, and then Mira and Serge Sultanim. They got it in 95.81. You ready for the next one? Here we go. What are the best reagents for the following conversion? So we have 38% answered 1, 57% answered 3, and 5% answered 4. Before I give you the correct answer, let's go over the question. So we have cyclohexene. And we want to go into 3-methoxy cyclohexene. Let's go over the choices that we have. Choice number 1, cyclohexene with chlorine and light. What kind of product do you get? Pardon? Okay, so you will get this. That's what you said, Abir, right? You agree? Of course not. You will get that in the absence of light. You will get a substitution product where you will get the allylic chloride. It is a radical reaction. And then you added sodium methoxide and methanol. What would be the product then? Elimination. So with the sodium methoxide, you will get this product. Correct? Fine. Option number 2. What do you get? Option number 2, you will protonate and then you will add OCH3. So basically, you will get simply methoxycyclohexane. So the first step is the formation of a carbocation. And then the nucleophile will attack. So you will get methoxycyclohexane. Number 3, the first condition, you will get 3-chlorocyclohexene. And methanol, then you will get the substitution product, not the elimination. So that will get you the product that you want. Cl2 and methanol, what do you get with Cl2 and methanol? Cl and OCH3, and they are trans. It's like adding water and Cl2. You're adding now CH3OH and Cl2, right? So first you will get cyclochloronium ion, and then the nucleophile will attack. With the water, the lone pair of oxygen in the water, it attacked. Here you have methanol, then the lone pair of oxygen will attack. So the correct answer, therefore, is number 3. Let's see the fastest responders. Here we go. Samir, Al-Alam and Amjad Kanj, Rayyan Talawi and Farah Sbaiti, they got it. Samir and Amjad, they got it in 9.55 seconds. Rayyan and Farah, they got it in 56 seconds. Omar and Abir, they got it in 39.47. Ali and Khudr, they got it in 40.48 seconds. Muhammad and Ralph, they got it in 49.56 seconds. You ready for the next one? Here we go. What is the kinetic product of the following reaction? %95 answered number 1. Good job. That is the correct answer. So you need to add the D+. You will form the allylic carbocation. And then you can have two different allylic carbocations. The first one will be this one. Or you can add no. Now this one has a resonance structure while this one has another resonance structure, which is this one. So how do we decide which allylic carbocation do we form? We have a tertiary carbocation, secondary carbocation. We have a secondary carbocation, secondary carbocation. So we have to add so that we will form this carbocation. Now, the question states that this reaction is a kinetic reaction, or you're doing it under kinetic conditions. Therefore, you need to go for the more stable carbocation, which will be this one. Then Cl minus attacks this plus, and therefore that will be your product. Let's see who are the fastest responders for the correct answer. Yeah. Patrick in 14.28, then Ryan and Farah in 22.64, Zena and Yusuf in 27.23, Ibrahim and Khalid in 33.23, Christopher and Ghassan in 33.58. Okay, you ready for the next one? Here we go. What is the product of the following reaction? 85% answered 3, and that is the correct answer. This is a Diels-Alder reaction. And the Diels-Alder reaction is also a stereospecific reaction. Therefore, if you start with a dienophile where you have the substituents to be cis, you will get a product where the substituents are cis. You need to have a cyclohexene. So these two are automatically out, 1 and 2. You do not have the double bond there. And then with these two, the two cyano groups are cis. Here, they are trans. Therefore, you will go for number 3. Let's see who are the fastest responders for the correct answer for this question. That will be Georgios and Reem in 9.84 seconds. Ghassan and Sarah in 27.52. And then Samir and Amjad in 31.06. Omar and Abir in 34.08. Anis and Emmanuel in 42.58. You ready for the next one? Here we go. Which compound would undergo solvolysis at a fastest rate, or at the fastest rate? %, answered 1, 13% answered 2, 46% answered 3, and 31% answered 4. This is a solvolysis reaction. What is the rate determining step for a solvolysis reaction? Carbocation formation. When you are forming the carbocation of number 1, the cyclopentadienyl cation, what kind of cation are you forming? Anti-aromatic carbocation, which is very unstable. We agreed that the bond between the carbon and bromine, when the carbon is an sp2 hybridized carbon, it's a very strong bond. You cannot form the cation out of a benzene. So that is out of the question as well. Number 3, what kind of carbocation would you form? An aromatic carbocation. You have complete conjugation, Huckel's rule, for n plus 2, cyclic, monocyclic, and planar. That will get you an aromatic carbocation, very stable. While here you are simply getting a tertiary carbocation. The aromatic is the most stable, therefore the correct answer is 3. Let's see who are the fastest responders for the correct answer. That will be Omar and Abir in 11.23, Ali and Khudr in 21.98 seconds, Anis and Emmanuel in 34.3 seconds, Hiba and Serge in 46.66 seconds, Samir and Amjad in 51.19. You ready for the next one? Here we go. What is the product of the following reaction? %, answered 1, 67% answered 2, and then we have 3% who answered 3. Well, what kind of reaction is this reaction? Hydroboration oxidation. Hydroboration, what do you know about hydroboration oxidation reaction? It is anti-Markovnikov, that's correct, and syn addition. Now in the hydroboration step, what happens? Now, BH2 will add to the less substituted carbon and hydrogen to the more substituted carbon. That's why it is anti-Markovnikov, right? In the second step, BH2 is displaced by an OH group, right? Fine. And it is syn addition, which means that we need to add the OH and the hydrogen syn. Therefore, here we have the H and OH trans, one is out. H and OH, they are cis, H and OH are trans, 3 is out. But by simply knowing the features of the reaction and looking at the choices, you can take 2 choices out. Because you need the OH and H to be cis. Now, we need to decide which carbon is the less sterically hindered carbon. That less sterically hindered carbon is going to have the OH carbon, the OH group. Therefore, the correct answer will be 2. OH is going to the less substituted carbon. Let's see who are the fastest responders for the correct answer of this question. That will be Fatima Slim and Karen Sayyad in 9.94 seconds. Patrick in 20.44 seconds. Zaina and Yusuf in 20.64. Zainab and Hussein in 24.33. Christopher and Ghassan in 29.25. That will conclude our session.